In this video, I will talk about substitution. The video will cover C1 and F1. First, let's look at the difference between an equation and a formula. An equation might look something like this. 4x plus 3 equals to 11. In this case, the question is to solve the equation. We can use bar modeling or some other way, and we'll find that x equals to 2. X in this case is called an unknown, for which we don't know the value until we have solved the equation. But at that point, x is definitely 2. There is no other way, and whatever method we use to solve it, x will always be 2 for this equation. If we look at the formula, it might look something like this. b equals to 4x plus 3. Can we solve this? Can we find the value of b or the value of x? No, we cannot, because we don't have enough information. In this case, x is called a variable because we can substitute different values into the place of x and find different values of b. b equals 4x plus 3 is a formula, and we can evaluate that formula for different values of x. Let's evaluate it, for example, for x equals to 7. If x equals to 7, then after substituting this into the place of x, we find that b equals to 4 times 7 plus 3. Remember, when there is a number next to the variable, that means multiplication. So 4 times 7 is 28 plus 3 is 31. In this case, b equals to 31. But we can look at another example when x is not 7, but x is 8. And we can evaluate the formula for this new value of x. If we substitute x equals 8 into the place of x, we find that b equals 4 times 8 plus 3. b equals to 35. So when the value of the variable x is 8, b will equal to 35. We can see that the value of b depends on what the variable x is in the given question. We can also use negative numbers, so for example we can say that x equals to -2, and if we substitute that in the place of x, we find that b equals to 4 times -2 plus 3, which is -8 plus 3, -5. So when the value of the variable x is -2, the formula can be evaluated and we find that b equals -5. Moving on to F1. Here we will substitute positive variables into one-step formula. Look at these 4 examples. They cover the 4 operations. The first one is b equals 15 plus a. In this case, my variable is a, and the value of it in this specific question is 3. So if we substitute 3 into the place of a, we get that b equals 15 plus 3, which is 18. Moving on to the next question. Here a equals to 3, and the formula is c equals 15, take away a. So we have to substitute 3 in the place of a, and we find that c equals to 15, take away 3, which is 12. The third question is multiplication. Remember, 15a means 15 times a. There's a hidden multiplication sign when there is a number next to the variable. So we substitute 3 in the place of a, and we find that d equals to 15 times 3, which is 45. Lastly, we will have division. Again, 15 over a means 15 divided by a. The fraction line is a division sign. So if we take the value of the variable a to be 3, then the formula can be evaluated as 15 divided by 3, which is 5. E equals to 5. Moving on to slightly more complicated examples. If my formula is g equals to 2 to the power f, then the variable is in the power. And if we take the value of the variable to be 4, then after substituting, we have that g equals to 2 to the power 4, because f equals to 4 in this question. Remember that 2 to the power 4 means 2 multiplied by itself 4 times. So 2 to the power 4 equals to 16. The value of g is 16. Lastly, we have a formula where there are 2 separate variables. The formula goes like this. K equals to the j's root of h. We have to substitute 3 in the place of j and 64 in the place of h. Let's do that. K equals to the third root of 64. Remember that finding the third root of something means we are trying to find a number which was multiplied by itself 3 times to give us 64. What was that number? It is 4. So the third root of 64 is 4. The value of k is 4.